Hi, and welcome to this presentation on correlation coefficients and p-values. My name is Jim Raduca, doctoral candidate for Educational Technology Leadership at New Jersey City University. These are the key terms we will be discussing as we calculate and report our findings on a relationship between two variables. This tutorial will illustrate how to calculate the correlation coefficient and the p-value using SPSS. We will then apply the decision rule to see if there is a significant relationship between two variables. The correlation coefficient is represented by the variable r and has a range between -1 and +1. This number tells us the strength and direction of the relationship between two variables, such as time spent on an educational software program and increase in test scores. An r value of either -1 or +1 illustrates a perfect linear relationship, where 0 illustrates no linear relationship between the variables. The closer to 1, the more confident we are of a positive linear correlation, and the closer to -1, the more confident we are of a negative linear correlation. These 5 scatter plots show the various relationship between two variables, their lines of best fit, and their r values. Correlations that slope upward from left to right have positive correlations, and correlations that slope downward from left to right have negative correlations. The closer the points are to the line of best fit, the closer the r value is to 1 or -1. If there is no linear relationship, the r value is 0. It is possible to estimate the strength of the calculation just by looking at the bivariate data on a scatter plot. Can you guess what the correlation coefficients are for the 3 scatter plots illustrated? You can practice visual estimations by going to the website at the bottom of this slide. The next few slides will demonstrate how to calculate the correlation coefficient R and the p-value using SPSS as described in step 1. In step 2, we will compare the calculated p-value to alpha, where alpha is the significance level set at 0.05. The p-value will determine the significance of the relationship between two variables, which will bring us to the decision rule. If p is less than or equal to alpha, there is a significant relationship between the variables. And if p is greater than alpha, there is no significant relationship between the variables. To calculate the correlation coefficient r, the bivariate data, meaning the x and y values, and the number of pairs n, are factors of the calculation as seen in this formula. Using a program like SPSS helps to simplify the evaluation process. The calculation in SPSS will also include the p-value, which will influence the decision rule. It is important to consider that the size of the sample population n has a major influence on significance. A strong relation may not be significant, and conversely, a weak relationship can be significant. The link at the bottom of this slide will allow you to input parameters r and n and instantly see the results for significance, which is the p-value. Here is the scatter plot for the variables weight and height. Can you guess the value of the correlation coefficient r? Is it positive or negative? Strong, moderate, or weak? Let's look at the results from SPSS to find out. Here are the results from SPSS. With n, the number of pairs of the variables weight and height, equal to 39, the r value shows a moderate positive or uphill correlation. The p-value is 0.001. This brings us to the decision rule. Suppose we are trying to determine if the relationship between weight and height of people is significant. Then we start with the null hypothesis, which in this case is a statement there is no relationship between weight and height of people. The p-value is a number between 0 and 1, representing the probability that this data would have arisen if the null hypothesis were true. Once we know the p-value, we compare it to alpha and make a decision. Here p is equal to 0.001, which is less than alpha, or 0.05. Therefore, there is a significant relationship between the variables weight and height. Here we are in SPSS. We are going to calculate the correlation coefficient R, and the p-value for the variables weight and height, where n is equal to 39 pairs. To do this, we go to Analyze, Correlate, bivariate, because it's two variables, weight and height, and we're going to place these variables into the variable column. Weight is already chosen. We'll choose height, place that into the variable column. We are going to calculate the Pearson R, one-tailed, and we're ready to calculate. I hope this presentation was helpful. Thank you for listening.